Hello IB, welcome to chapter 19 where we do applications of integration. So 19A looks at the area under a curve. It's just a short section and it pretty well goes over what we were looking at earlier. You've probably explored lots of these things already in chapter 18. So the area between a curve f of x and the x-axis between A and B can be determined in two ways, either using areas of shapes, that's if we've got straight lines or linear functions, they're just those geometric shapes, or by this definite integral, which you did in the last section of chapter 18. So that's from A to B of our function f of x, and remember f of x needs to be continuous and can't have any sharp points like in a modulus function. And here we have x is between these two boundaries. The areas above the axis are positive and the areas below the axis are negative. So you hopefully came across that in chapter 18. If not, it goes into this in a little bit more detail in this section. So let's start off with that geometric possibility. So here we've got a straight line. We've got the area. We want to find the area enclosed between y equals 2x. So here it's important to note all the boundaries. You can highlight this if it's in an IB question. So we've got y equals 2x, our linear equation, the x-axis. So we've got our y equals 2x, our x-axis is they're the two vertical ones. Then the horizontal, the x boundaries are between x equal to 0, and that's okay, it's a point of intersection, and x equal to 4. So if we ever want to get an area, we usually need, or in this sort of case, we need 4 sides to it. You could do that because it's a triangle with half base times height. Our base is 4, the height is 8, so you should be able to do that one. That should be easy. This you could do on a calculator page in your GDC and just put that into your calculator to come out with our 16 units. And you should be able to do it without a calculator by just doing your integration and then substitute in the boundaries of 4 and 0. So that should be with and without a calculator. Plus minus, if that makes sense. Down here, this next one here where we've got the function y equals 1 over x and our boundaries are the curve, the x-axis, x equals 1 and x equals 4. So we've got our curve which we've drawn on, our x-axis, our x equal to 1 and our x equal to 4. So that's a 1 here. Board wasn't working very well. So integrating that, again, you could do it with your calculator, but let's do this one without. So our boundaries are from 1 to 4 of 1 over x dx. Integral of 1 on x is natural log of x. We could put the absolute value signs in, but I guess I've noticed that these are both positive values, so there's not an issue. ln of 4 minus ln of 1. Our pens didn't work here before. So there's our ln of 4 because ln of 1 equals 0. Hopefully you know or remember that. So that you should be able to do without a calculator at all. That gives you the exact answer. If you want a rounded answer, then you're using your GDC. This next one here is an investigation where it looks at that whole negative. So we worked through that. If you've looked at this already, you might be able to do it without your calculator. The question is, when we get our integral from a to b of f of x dx, do we always get an area? Obviously, if a equals b, there's no area to consider, but do we always get an area if they're not equal? So we looked at these two areas of x cubed, and you should be able to come up with this cubic function here, and then think, what's the area from 0 to 1? And what about from minus 1 to plus 1? So you, depending how you've thought about it, the area, let's shift this a little bit over, this area comes out at 0.25, and you should be able to work that out from around here. The integral of 0 to 1 of x cubed Where can we do it? It's sort of down here. This is for a later question. The integral of x cubed dx is x to the 4th over 4. So if your boundaries are, if I just come over here, it's going to get a bit squeezy. Let's do it in a different colour so it's a bit easier to see. That's going to equal the boundaries x to the 4th over 4 with our boundaries of 0 to 1, which is equal to 1/4 minus 0 substituted in goes to 0. So we're left with 1/4. So our area, this is positive 0.25. This is negative 0.25 because it's exactly the same, but it's below. And when you take the integral from -1 to +1, the net result is 0. So you could either have done that with your calculator or done it manually. So an integral does not always give us an area, because in this case we don't get the area because they've cancelled out completely. It's like the net result. We've talked about that graph. In this one here, why is your answer negative? This one from -1 to 0 is below the x-axis, and that's when we find that it comes out with a negative. If we go from -1 to 0, that's this area, plus 0 to 1, that's that area, then we end up with minus 0.25 plus 0.25 equals 0. So you could put all that into your calculator and test that result. What if we go from 0 to -1 x cubed dx? What does that mean? When we do -1 to 0, we got this answer. All right. If we go from 0 to -1, then we end up with a positive answer. So remember that if we go 0 to -1, that's the opposite of going -1 to 0. So if we've got an area underneath the curve, it's the same, like basically you can change these boundaries around. If they swap, then it's the negative of the integral. So even though it doesn't make sense to think about that, like how do you get an area where the lower bound is 0 and the upper bound is -1, doesn't make sense, but that gives us a positive value for the area. It's almost like you're looking at it upside down, would be another way, but I'm not sure that's a very mathematical way. So if our function is below the x-axis for all of that region between our a's and b's, then we want to get the negative of that area to, if we actually want to get a positive number for the area. Area is a positive thing, so we need to take the opposite of what the integral is. We take the negative of the integral. So that's what 19A was about, just looking at those areas and that whole concept of having a positive area above the curve and a negative area below the curve. Thanks for listening, and we'll look at 19B next.